Welcome on board to our presentation using Docker for fast and easy testing with MariaDB and MaxScale. Very long title. I introduce myself. I am Alessandro Fustini. I'm a senior developer and MySQL and MariaDB DBA. And introduce Andrea Tosatto, my colleague, Docker fanatic, a software architect and a cloud evangelist. We work in Colt engine in Turin, Italy, and are a web hosting provider, partner of MariaDB. I like to say Colt engine is a company Italian powered and powered by MariaDB. We have 4 brands: Happy Cloud for OpenStack solution, Colt Academy for online course like SEO, Joomla, and WordPress. Joomla Host is a hosting company, web hosting company specialized in Joomla hosting, and NSC hosting for hosting provider and virtualization solution. Okay, this is the agenda. We are talking about evolving our LAMP stack, compatibility with MaxScale, why use how and why use Vagrant and Docker and Docker Compose, and give some example for this. 1 year ago, we have to evolve our LAMP stack. The M of LAMP is normally is MySQL, and we want to use MariaDB instead of MySQL. We have another problem too with MySQL. We have an old version or end-of-life version of MySQL. When we try to upgrade with this platform, we have some problem because we have a bunch LAMP stack. We have in a shared hosting LAMP stack is very normal to have uncontrolled PHP file because all user load our application, and we have not a control of this kind of program or framework and so on. We have to use MariaDB 10 because we have more speed and we have more security, but where are our problem? The real problem is the SQL inside or in the script, because we have a bunch of PHP file with often at least one or more SQL statement inside it, and we have no way to patch it. And we want to perform a transparent upgrade for our user. A typical example for us is a create table, because create table is in an old style have a type or engine specification for table engine. But in new version, only engine is permitted. When we after this briefing we found and use MaxScale to fix it on the fly. But what is MaxScale? MaxScale is an active SQL proxy built by MariaDB with a plugin system like authentication protocol, monitoring, routing, and so on, where a plugin is a query rewriting with regexp. When you catch the single statement, and you can rewrite it on the fly and pass it to the database. With this plugin, we convert on the fly all the SQL statement to the new system. Okay.
Okay, give me 1 second that I just drink some water. Okay, very well. So actually, at that time, MaxScale was in beta, so that's of course a problem. And the other problem was that MaxScale was a new technology to us, not only to the community but also to us. What we would like to realize is to find a way to test MaxScale before, and for testing I mean actually prove its effectiveness and reliability before pushing that technology in production. We work a lot on it with the guys from MariaDB because we had the urgency to push MaxScale in production to deprecate our old Mysql databases. But the fact is that that technology was still in beta and it was still new. So what we decided to do is to find a way to test MaxScale on our laptop, loading and routing all the traffic that usually our customers generate on our web application servers, and find the best way to test in local and learn it. Coming from the web hosting world, the first tool we think about is Vagrant. Vagrant has been a really disruptive technology, especially from the people that work on the web, because it allows to automate the provisioning of virtual machines on your laptop with a simple Vagrant file that commands the provisioning of VirtualBox VMs. Vagrant was a really good solution to us because it supports many configuration management systems by default, like Puppet, and it also allows to share these provisioning receipts with your teammates, build in the same way your VMs. For us, it was also really important with this experiment to build something that fits both developer and operations guys, because we were planning to deploy in production a new piece of our stack, but the fact is that this solution was coming from not the operation guys but the developer. And so for them was really a winning option with Vagrant, the fact that we were able to use the same Puppet classes we use in production to configure and to test the provisioning in a local VM. But the fact is that Vagrant is no more hot as a technology because it has been definitely passed by the advent of Docker. Docker is a really, really, really disruptive tool and is definitely the tool of the moment because leveraging Let's See C groups and namespaces, it allows you to build a sandbox testing environment for application, and also with the same pipeline that you use in local, you can push in production these images. Vagrant is based on VM, and that means that using VirtualBox, we were able to grant the multi-platform compatibility of our testing pipeline. Well, also Docker can be multi-platform via a sort of hack that is Docker machine or boot Docker. These tools allows on Windows and on Linux, on Windows and on machines and OS X machines to using a tiny VM to deploy container, even if it is not natively supported. Docker is not natively supported on OS X, and the support for Windows is something that they announced on Microsoft Build 2015 on the beginning of this year. So it is still something that is not generally available. The fact is that, as I said, Vagrant provides automation to the workflow, and Docker by itself does not provide automation. It is only a tool to contain and ship application. We found in Docker Compose a solution to perform automation to our workflow. Docker Compose is a tool developed by the guys of Docker. It was previously a community work. It was called Fig. I don't know if you are familiar with the history of Docker. when they begin with this product, they were actually realizing a platform as a service, and they were really on Docker, not on the tool. Suddenly, Docker widespread to the community, and so they decide to bring into Docker some tools developed by other guys. And Docker Compose, that was called Fig before the acquisition by Docker, was actually one of these tools built by the community to automate and orchestrate the provisioning of a container. Basically, the idea of Docker Compose is to add Docker Compose YAML file that specifies the infrastructure that you want to provision, and this infrastructure is specified in terms of Docker containers. Furthermore, what I believe that is really a disruptive feature of Docker Compose is that it uses the same semantics, the same operation of Docker itself. So I can start up an infrastructure and a bunch of containers using the same compound that I would use with Docker. Any of you is yet familiar with this tool or Docker? How many of you use Docker Compose? No one? Docker? Yeah, great, okay. Okay, as you can see, the syntax of Docker Compose, if you know Docker, is really simple, because the root key of the Docker Compose file are the name of the services that I would like to provision. And what I found in the tree under the root keys, under the service, as the same command that I will usually pass to the Docker run command to actually run a Docker image. For example, this first services is built from a Docker file that is contained, in this case, in the local path. And I can specify that these services needs the database services to properly run. So as you can see, I can finally define the dependency between services in an easy way. And moreover, I can define the ports or paths, like in this case, environment variable. Everything is defined within a file, and running the Docker Compose app command, I can provision the whole stack and test it. Just for reference, I report here an example of the Docker file that we used. This example actually is a traditional LAMP stack with Joomla pre-installed within it. And you can see from the Docker file of the Joomla services, because it sends the PHP Apache official images, installing with this run command the Joomla in the web root folder. That's basically the idea. So we found in the Docker Compose a way to actually test and learn MaxScale. Docker Compose was really effective because it was a common language for the operation guys and we developers. Even because Docker and Docker Compose were new technologies to both. So we were starting from the same point, and we were finally on the same path, and we were working together to find a solution to the problem that, of course, our company was facing. As I already said, with Docker Compose was really easy to build test setups. Moreover, it adds to Docker the capability to scale. I can, on the fly, say that I would like two services of that kind. For example, I can duplicate on the fly the database services, or I can duplicate the web application Apache image. So on the fly, my infrastructure can scratch up or scratch out. Moreover, using Docker, as I said, it was easy to reuse the same container that we already built for the test environment to actually push in production or in staging MaxScale. In fact, as a testing, for us was really important to lower the impact of the introducing of a new technology on the stack that actually we were using and we already tested for years. And so Docker was a solution because it would allow us to introduce a new piece of technologies, and if something was going wrong, we could easily roll back without reconfiguring our server from scratch to the previous setup. So Docker Compose to us was really that option. If you have read the outline of this presentation, now what we will do is to show you how we use Docker Compose to test the main feature of Docker Compose, of MaxScale, sorry. All that we will show to you is based on our real experience, are snippets taken from what we really did, and can easily find on our blog the full entries, the full script on our blog or on the MariaDB blog. So if you want more references, you can just Google it and you can easily find the stuff that we will show you. We will start from the regex filter. As Alessandro said before, we were facing the problem to support both the syntax for the creatable statement, but this, even if MariaDB 10 deprecated the legacy one. And what we did is to, because we will looking for a solution that will allow us to be transparent with respect to our customers, is to on the fly rewrite the legacy queries to the new syntax. And what we have done using the regex filter, the MaxScale regex filter, is actually to allow both the syntax in the proxy and to output the query in one supported way. I will show you the simple setup, that you could that would allow you to test this functionality of MaxScale. And actually, we have a MaxScale container that acts as a proxy to the database. In this time, we just for simplicity, use only one database instance, but you can easily scale. If you patch the configuration that we will show you of MaxScale, you can easily allow your configuration to be aware of the changement of the environment, and so automatically scale within this layer, with respect to this layer. So as I show you, we have MaxScale, that is our query entry point. So it listen on the standard MySQL port, and MaxScale is linked to our database, and that is in this case a simple MariaDB 10 server. How many of you? You said that no one knows MaxScale. How many of you knows MaxScale? Okay, only one. So I will spend some time explaining the configuration. The configuration of MaxScale is contained in this file, maxscale.cnf, and it is actually composed by different sections. The first section is the section of the listeners that allows you to specify which are the entry point of your proxy. In this case, we have got only one listener, so one active MySQL connection, incoming MySQL connection. And the listener is listening on the standard MySQL port, and it is talking the MySQL client protocol, and it is linked to these services, that is this one, that actually what it does is to apply on the fly the regex. Services could be of different kind. For example, here we have a read-con route that is actually service that accepts the incoming queries, and it propagates the queries to the list of nodes defined within the server's configuration. It uses this credential to authenticate to the database services. And as you can see, we call it the regex service because this service actually apply on the fly the filter defined called regex filter. So we have got a unique entry point on our configuration. This entry point is linked to these services, to this service. This service actually perform on the fly regex rewriting of the query. And this filter, as you can see, matches all the string with this regexp and replace this regular expression with the engine on the fly. This is really simple, I believe. And what it does actually does is what we are expecting. So our customer could use both the syntax, the type, or the engine keyword, and what our server, the node one, see is only one kind of creatable statement, the one using the engine keyword.
Can I already ask you a question?
Yeah, for sure.
If you have forum software and people are talking about great, about exactly this query, would the new command also have the find replace applied?
Yes.
So then.
You can compose more filter.
No, I mean this exact filter will also just apply on insert if you have an insert.
Yeah, using that keyword, yes. Yes.
Okay.
In this case, it's only the simplest example. Of course, you can build more complex regex.
Okay.
So this is the simplest one. You can, for example, match, create star, and then so have any kind of characters between the create and the type statement, and that possibly will fix the problem that you person. Yeah.
It is easier for alter table too. Is regex a bit different because there are the same problem for create table and alter table. Okay.
Yeah. Yeah. This is the simplest one. Of course, in production you should be more precise.
Expressive.
You know, irregular expressions are pretty a mess, so I wouldn't like to confuse you with strings or match patterns and something like that. So, good point. Another feature that is really interesting and actually used in production of MaxScale is the T-filter. Actually, what it does, the T-filter, is to replicate the traffic incoming to different group of database on the backend. It is something that can be used, for example, if you would like just to apply some kind of statement to another group of database. Let's assume that you are performing some statistics and you don't want to query the production database to perform the statistics. You can split the incoming traffic to a cluster of databases specifically designed for statistic queries or batch processing. And this is really, really easy. So we can, like looking at the picture, this is the incoming traffic. MaxScale for us automatically duplicates the traffic, and we can assume that here and there are some databases that are receiving the incoming traffic. It is something that by default is not related with master-slave replica and something like that. It's just a way to duplicate the traffic within MaxScale. Again, the simplest architecture that we can imagine to perform an example, to test this feature, is one composed by two database servers, one with MariaDB 10 and the other with MySQL. It doesn't matter which kind of version you use. And looking at the MaxScale configuration, you can see that here we have got again one unique entry point to MaxScale, this listener. This listener is linked because I forgot to tell you that the listener are linked to one service. With the T-filter here on the so this listener is linked to the DB service. What it does, the DB service, is to leverage the T-filter, this one, to duplicate the incoming traffic first to the servers to which it is directly connected, and then to the server that the replica server service as defined within the T-filter, as defined in its configuration. So again, we can imagine our query coming to the service. From the service, the services make use the T-filter, so it sends the query directly to the server specified here, but within the T-filter, these queries are also replied to this node. Okay, is that clear? Okay. We use it actually in our experience because we went to production in steps. And the first step that we attempt is to keep our legacy infrastructure up and running and use a T-filter to replicate the traffic both to our legacy infrastructure with MySQL 5 and to our new infrastructure with MariaDB 10. So actually, our use case of MariaDB, of MaxScale, was using both the filter and the regex filter to keep up and in sync both the infrastructure without involving replica, master slave, and something like that. Okay, we are not using in production Galera, if any of you were asking. Okay. Is that clear? Okay, move on. Okay, that's a feature that I personally really like, coming not from the database world, I'm honest, is the read-write split. Okay, I've seen many times applications taking care of this logic. So splitting the loading between master database for the write and a bunch of slave databases for the read. With MaxScale, you can finally move this logic to the proxy without involving your application. So your application doesn't have anymore to implement this kind of logic because MaxScale does it by itself. So this is the incoming traffic. The read-write split of MaxScale split the traffic according to the operation. So the write goes to the master, for example, and the read goes to the slaves. Okay, the simple setup that we can think for this test is that one, I changed the base image for the database. I used the one from Tutum. I don't know if you know them. They are one of the most advanced Docker as a service provider in the world, and they did a really great work building the first images for the community. And their MySQL image has got inside with this environment variable the capability to create on the fly with a Docker Compose app master and slave replication. So that was testing, and we decided to use this image.
Rewrite split take care from translation context because it's not so easy mismatch when you set you write and a master and select for update or is a translation code.
Yeah. See, MaxScale is completely aware of the MySQL protocol, so that means that it's completely aware of the transaction. That's in fact a good point to use MaxScale instead of HA proxy or some proxy that is not aware of the MySQL protocol. So the MaxScale configuration again is really simple. We have, like before, a unique entry point to MaxScale. And we have a new piece that is called monitor in MaxScale. Monitor essentially is something that MaxScale uses to monitor the status of the servers. So that means that the monitors read the configuration from the server dynamically, so it can also know if something changed in the configuration, and reads dynamically with that check interval. So in this case, every 5 seconds, check the configuration of our node. And we use it because to implement the read-write split properly, we should be aware of which node is the master and which node is the slave to properly route the query. So the read-write split is actually a different kind of service, no more the read-con route, but the read-write split router. And this is attached to our two nodes. Here it says that the connection to the slave, all the slave has got the same probability to receive incoming read queries, because by default MaxScale does not use these semantics, because, for example, and it is something that we use in production, we have got a slave that we use only for the dump. And so maybe in our case, we wouldn't like to have incoming query to that slave because it's locked when we do the dump. Again, these are the configuration, the user and password to connect our nodes. And this is, as you can see, this is actually really simple because MaxScale with this router takes care of all the logic. So basically specifying the router, the servers that we want to insert to use for this kind of service, and the policy of slave engaging we have implemented on the proxy read-write splitter. Okay, is that clear? Okay, let's move to the last example. Okay, the last example is actually something that is still on the way, because in the recent version of MaxScale, the 1.2, they have implemented in MaxScale in the monitor an event mechanism that could be used maybe in the future to perform auto failover of the when the master goes down. So as you can see, we have got a bunch of database. These two with the blue t-shirt are the slave. The one with the bay cap is the master. And when the idea is that when the master goes down, we would like to let MaxScale elect a new master. Okay, that's something that maybe in production we will never use, but this is just to give you an idea of the direction that the MaxScale development is taking. So, as I said, the idea is that when the master go away, the obey cap, so the master, is the best slave. Okay, again, we got here in this example, I didn't report all the DB involved, but we have 3 databases, 1 master and 2 slaves. This is the master, those are the slaves, and I didn't report, I don't know, okay. Here we have the Docker Compose specification of MaxScale. So here you can see that it's linked to 3 databases. To be fair with you, here I show how we extend the MaxScale base image we developed to support this failover logic. Basically, we are using a tool developed by one of the guys of MariaDB. It is actually something that does not to be used in production. It's only a showcase. And this is a Go tool that automatically receives the events of master down from MaxScale and contacting the alive database servers, use an heuristic to determine the best master. This tool is wrapped in a script that we call Mysql failover, just to let you find yourself when I will show you the MaxScale configuration. Okay, as I said, this logic is something that has been implemented within the monitor. So from MaxScale 1.2, the monitor does not only read in this example every second the configuration of all the database servers, but also is able to propagate events when something happens, like in this case, master down. We have got a lot of other events. For example, master up, slave down, slave up, and something like that. You can find easily on the documentation of MaxScale. And so, what we have specified here is that when the master goes down, we would like to run a script. It is the failover script. Okay, so this time our router is not performing any read-write splitting, so maybe I would have dropped that line, no matters. And we use the readcon route that balance the traffic to all the servers, and in this case it balanced the traffic to all the nodes. And these database servers are configured in master-slave replication. Okay, let me show you this script. This is the way that we use. This actually is coming from an example from MariaDB. This is the way that we match the arguments passed by MaxScale to the script, to the failover script. And this is the way, the command down here, this is the way that we elect a new master. So we use, as you can see, we use a force policy. That is something, the worst fit for this case, because we want to force, for example, the master election. And so, just to explain you something, those are the credentials. Those are the credentials used to connect for the replica user. This is the host list that is coming. All these information are coming from the MaxScale argument, and this is the tool MariaDB Rep Manager that we use to test this feature. What it happens is that when we stop the master container with Docker stop, what happens is that before stopping the master, the configuration is exactly that one. We got the master running, two slave running. When we stop the master, what we see is that automatically MaxScale propagate the master down event, and our script automatically elect a new master, that one, and you can also see that the master ID has changed here, okay, and here. Okay, I don't know if you see. So what happened is that we've got a new master, and MariaDB and MaxScale automatically is aware of that changement in the configuration, and automatically is able to let the master election be transparent with respect to our client. So it's something that is hard to use in production, because maybe it's better to check the status of the slaves. This example is only a way to show you the direction that MaxScale is taking. So to become something where event can be propagated to, for example, inform our database administrator that the fact that the master is down. In this example, we do not take care of the master up event, but what it happens if this master is up, in our case, is that this master has been not pulled in the cluster by MaxScale, so it is frozen. The queries does not go in. MaxScale does not route the traffic to this master because, of course, he is not aware of his status. So basically, this is the idea. To recap, what we have done with MaxScale is to implement easy, let me use this term, easy and effective way to grant the retrocompatibility from MariaDB 10 to MySQL 5, and we actually use it a lot. And what we experience also is that MaxScale could be a winning solution to implement MySQL H availability in terms of read-write splitting. Okay, in our case. What I really like of this experience is the fact that Docker has been proved like a common language, a common tool for developer and operation guys. And this is really, really important when you work because before Docker, very often the situation, especially in our company, I don't know in the others, but I suppose it's the same. Very often the operation team works like a silos, the dev team works like a silos, and then when you have to push something new in production, then the war begins. And with Docker, you have a common tool. We have something to prove that, as a developer, to prove that your solutions are effective. And as an operation guy, you have something that you can fix for developers because you share a stack, basically. And finally, Docker Compose is really, we believe that is really a powerful learning tool because, of course, we didn't use Docker Compose in production, but it has been really, really useful to replicate or reproduce our development environment many, many times, testing the different configurations. Okay, I hope that I'm in time. I suppose there are 10 minutes for questions, so thank you. Okay.
Can you the read-write splitting?
Okay.
Does it also work for longer transactions, which, for example, start with a select and then do an update?
Sorry. Ha chiesto se il split supporta anche le transazioni lunghe, quindi che iniziano con una select. Yes.
Yes.
Okay.
Yeah.
Do you know how?
Is internal of MaxScale because it's a SQL proxy and understand when start a transaction and when end a transaction.
So you're asking within a transaction.
Yeah.
Okay. So
for a long transaction.
So if you have select first. So
yeah. So for update or no is a select into a transaction. No.
If you have a select. And most applications are dirty, they don't do a select for update. That's my experience.
Okay.
They do a select, and then later in the same transaction do an update. So it's changing the transaction from a read-only to a write state.
Okay, I suppose that the read-only, but it's only a supposition. I don't know very well if it supports the change of the type of the transaction. I suppose maybe Maria Luisa could tell us. I suppose that actually what it does is to perform the select on the slaves and the write on the master, because I think that it cannot be so deep in the awareness of the protocol. But I'm not sure about it.
I think what it does is, as we have the parser, we have the MySQL parser within the MaxScale proxy. So what happens is when you get the query or the transaction going through, the parser goes through the transactions. So if it ends up with an update that goes to the right as opposed to the master to be conservative.
Okay.
I think that actually happens to all transactions.
Yeah.
If you don't have auto-commit, then you end up in the writer, because you can't know if you're right later in the transaction.
Yes.
I'm not 100% sure, we don't use the restart.
Yeah, that should be the.
Because I think that's the case, because
You
otherwise
cannot-
you can have like 1 hour between the select and the update.
Because you cannot know what will happen in the future.
Sorry?
You need to have a predictor, otherwise this will happen
Yeah,
in the future.
if you want it to be able to split, then you have to use the auto-commit, or so then you can do it like one by one, or the transaction end up in the writer anyway.
Okay.
How do you implement hierarchy of MaxScale itself?
Huh?
How do you implement hierarchy of MaxScale itself?
Okay, you can, as you see, MaxScale is a transparent proxy, stateless, because the set state is on the database behind it, and you can easily, with Docker, for Docker Compose, for example, compose in parallel two different containers serving the same MaxScale configuration, and then you can load balance in any way, even with HA proxy, the traffic among the two or more MaxScale services. You can do it also with the server.
Yeah. In this case, you cannot perform any failover to MaxScale itself.
No, but if something goes, using a load balancer, if one service goes down, he knows it, and you just route all the traffic to
The
it.
is that you cannot perform database failover. Because you might end up with having two MaxScale, both of them trying to do a failover.
Yeah, of course, yes. In that, you are talking about the last example. Yes, you definitely wouldn't use it. Yes, because of concurrency. Yes.
And another question about the T filter.
Okay.
How do you guarantee consistency?
With the T filter, you are, you are not able you are not able to grant consistency because no. Okay, you are not able to grant consistency. You just split the traffic.
Yeah, duplicate the traffic. And the easy way to test the MaxScale 2 or a different configuration for database, because you send a single query and it's duplicated over the server that you defined.
Let's assume that you have a slow database and a fast one. You are definitely not able to grant that the state is the same. Okay. Any other question?
Do you experience any performance penalty because of the MaxScale filters? I mean, if you have a filter that's very complex regular extension, do you see that in the...
Okay, in our case, of course, MaxScale is a layer on the query, so it slows down the traffic. And it really depends by the performance of your regular expression, like everything, regular expression match the pattern, and so if you have very complex pattern, of course, there is a hovering time. In our case, the overhead was acceptable, but maybe it's not in all cases. We do not perform in-time, real-time analytics or something like that. So in our case, it was acceptable. It depends. But it's strictly related to the performance of the brackets.
The question was more if it was actually expected, or was it like slower? Or
No, it's actually, we use a really simple regular expression.
Yeah.
And the fact we didn't notice any particular slowdown.
What are you running the Docker containers on? What are you running the Docker
Nice.
containers on?
Okay. we are not we use for this test case we use as a host our production server that are running on CentOS.
So just on hardware.
Yeah, on our maybe if you would like to push in production containers, it's better to use something more supported like Ubuntu or CentOS 7.1 or Red Hat Enterprise Linux. And maybe I suggest you to use a management layer like Kubernetes, for example, or the tools from CoreOS to grant that your your container are up and running, and if something goes down, if a container goes down, automatically the management layer is able to spin a new instance up. So Docker Compose is not for production, that's the point. But it's a way to go to the production tool. If you are interested in container in production, there are nice tools that can rewrite the Docker Compose configuration to the Kubernetes one. So you can just, with a tool, transform everything to something that you can run with Kubernetes. Okay. That's also a point that we have to the choice of Docker Compose.
Are you using CentOS 6 for?
We use CentOS 6 before the.
One warning.
Before the deprecation.
Now, if you're destroying a lot of Docker instances at the same time, the server can reboot.
Yeah, we experienced that, but that's only a point of the new version of Docker. The whole one that we run weren't affected by that problem. It's something that is strictly related to the kernel.
Yes.
Yeah, we also had the same problem, and in fact, we are running our test fully on Docker, our testing infrastructure full on Docker, and we are using Ubuntu for that problem. Yeah. In fact, if you like Docker, CentOS 6 is not support because of the bug because it's a one fix. Just to know. Yeah, good point.
Maybe if you just want to remind people, if you're interested in MaxScale, there are other talks
Yeah.
about MaxScale.
Yeah, there is one from Ivan that was, I suppose, the first leader of the project that is talking about the internals of MaxScale. So if you would like to know something about the internals, like the implementation of the regex or the availability, you better go to Ivan. He's really good. Thank you.
Thank you.